Before we begin this talk, well, the title is Automation with Ansible, as you can see up there. Before I begin the talk, how many people are already somewhat initiated with Ansible or automation tools in general? Okay, a fair number of you. To preface this, I may rely on some of you to answer questions because I am not the most initiated on this right now.
Well, thanks.
Kind of silly coming from the speaker himself, but just know it might come up. But anyway, so good to see that some people are initiated, but good to see that some people are also not initiated at all. This presentation I prepared for mostly beginners kind of audience. People that have not really tried automation with these kind of tools anyway. They might have done some automation before with their own bash scripts and what have you. But these tools are probably something you should really look into if you want to automate your workflow, whether it's large or very small. So I wasn't really acclimated myself, actually. This is why I actually did this presentation, so I could learn. Kind of selfish, pretty greedy, but that's my reasoning. So again, the title is Automation with Ansible, but honestly, the Ansible part is not the most important part of the presentation, even though it is the main line of it. The theme of it is actually automation with X. I could have been talking about something like Puppet or Chef or automation with bash scripts, even if it came down to it. The idea is to really initiate people who are not initiated in this kind of topic quickly and easily so they can start doing it and see how great it is. So that's the main theme of the talk, and that's kind of what it's going to entail. But the reason that we chose Ansible for this is that I believe it's the one that has the lowest barriers, and it's really easy to enter. And we'll talk about why that is and why this choice was made. So with that said, let's get into it, I suppose. So this is the agenda for today. We're going to talk about what is Ansible, what can it possibly do, some of the main principles behind it, describing its design goals, the infrastructure of it, and then the terminology you need to get initiated to actually using it, and a little quick demo of it in action, and then a little bit of Q&A to end it off. So what is Ansible? I've been talking about it for a little bit already, but what am I actually talking about? So let's just have a little bit of a blurb. So we've kind of talked about it as some kind of automation tool, but it was written in Python. It's also open source. It's also free. You can check it out on GitHub. It has 19,000 plus stars. Pretty popular project, a lot of commits. And it has a pretty quick release cycle too, once every 4 months or thereabouts. So it changes pretty often and it adds new features, constantly changing, but to add new features that are very useful. And this is also one of the reasons why I think it's a good tool to get invested into, perhaps, because the community is there and it keeps growing, and to enter it is possibly something very beneficial for yourself. And it's not something that will just die off because it's constantly growing and changing very quickly. And so with those few tidbits out of the way, I used the word automation tool a few times already, I think. But I think Ansible is really more than that. And a lot of these tools are really more than just tools. Some of them are languages. They provide a language for you to automate with. They provide the engine, which you use the language to, which drives the language, rather. And with these two things combined, with the community that Ansible has built, it's become more of a platform than just a tool or a language or an engine. It's something that is living and growing and expanding, and something that you can participate in. And so given that, I think it's a good choice for you to try out. But really what's important is, what can it really do? What can this automation platform, tool, language, engine do for you? Well, it can do quite a few things. As you would imagine, different automation tools would probably do very similar things. And here are some of the things it can do, probably. Configuration management seems like a pretty obvious thing to automate. Application deployment, you'll see it come up pretty often because of the ability to orchestrate configuration management. When you have configuration management and orchestration together, you can kind of really start thinking that, wait, I can actually deploy a whole application through these two kind of features. And system provisioning is pretty obvious as well, to have a fresh system and then configure it and manage it and orchestrate it. And the last one is probably actually anything. Why do I say that at all? It's not just entirely hyperbole. It's mostly hyperbole, but it's not entirely hyperbole. When you have the above 4 points, does that not essentially allow you to do almost anything in terms of deployment and provisioning of your application or to your systems, your nodes? So probably actually anything if you can do the first 4 things. And it could be simple, it could be complex, but with those 4 points, you can do all of those things. So that's just a brief, what is Ansible? What can it possibly do? Now let's move on to the main principles, which is really the meat of the talk, to describe what Ansible actually, how it works. So design goals. There were some design goals that went into Ansible when it was first created. It had to be really simple. Simple is probably the mainline word here. It had to have really low, or be really easy to use. Very few moving parts, so you can easily manage it once you've installed it. You don't need to constantly do maintenance on your installation of all your nodes that you're trying to manage or automate. It had to have a very easy and descriptive language. So not everyone necessarily has coding skills or is part of that side of your company. But it would be nice if everyone, even though they don't have the same familiarity with coding, what have you, to be able to understand what is happening just by reading it. Very human readable. It had to be secure, like anything else. Don't want any security holes. And lastly, it has to be powerful. It actually needs to be able to do what you want to do. So 6 pretty simple design goals, and I think it makes sense. Some of the tools that are out there that aren't Ansible have maybe more moving parts, so it's harder to manage. It has perhaps language that is more difficult to read. But let's say, compared to a bash script, it can become daunting to read after a while. So having something that's easy to read is actually really important. And being easy to use is why I'm doing this talk in the first place, to give a low barrier of entry to enter this kind of sphere of the IT world that's become a very cemented fabric of this community. So with those design goals in mind, how was it achieved? How did it actually do maybe 6 of those things? So OpenSSH is really the only protocol that's used in Ansible. There's also some other protocols you can fall back on. It's not the only transport method for communicating between the controller and the nodes that it wants to manage. But OpenSSH is the default. And it's been around for a while. It's very robust. It's been well tested. That's why they decided to use OpenSSH. And so that brings in the security point, which is pretty important. The second point is there are no agents, because we only use SSH actually. So you don't have to install any daemons, or no daemons run on your nodes at all. There's no maintenance of those daemons. You don't have to start them up. You don't have to check on them every so often. So because there's no agents, they don't pull your controller node at all. The controller node just talks to them through SSH. Very, very simple, very low overhead. And it's very easy because, well, Node X doesn't have anything on it, actually. There is no Ansible on Node X. The only thing that Ansible is on is your controller computer. So you just talk to SSH and you do what you need to do. And YAML. So YAML is the language of Ansible. It's very easy to read, very human readable. Much more human readable to me than compared to something like JSON, which is also not terrible to read. But this is very easy. It actually looks like regular English, almost. So these 3 points were how I'd achieved some of the 6 things I listed before in terms of design goals. And I think it makes a lot of sense to me, the way they did it. So we talk a little bit about infrastructure next to kind of illustrate what Ansible looks like when it's doing what it does. And to kind of contrast that, we have an example with agents. So with agents, this is not Ansible. Ansible doesn't have any agents at all. So with agents, you have the controller computer, which could be something called the master, and you have your nodes. And each of them potentially has an agent. Let's call it agent X. And the nodes would have to continually pull the controller to talk to it and what have you. There would be a 2-way communication. But you would have it such that the nodes need to always pull the master at some point to talk to it. And you would need to maintain each of these nodes to have this daemon or this agent running in the background all the time. So it becomes harder to deploy because you need to install things onto your nodes. And it may become harder to maintain if it's a complicated system. So with agents is contrary to without agents. So there are no agents in Ansible. So the controller just talks to the nodes through SSH. That's really it, actually. There isn't much else to it, as I understand. Much like how you would SSH to your remote machine to do work on it, to send a file to it, this is exactly what Ansible does. There is no need for any other control mechanism. It's just SSH. So we now move on to some of the terminology that's involved in Ansible, which will then allow you to really understand Ansible stuff. I think I'm going to describe 6 of the terms next, but there are many, many more terms that are involved in Ansible that I won't be covering today. This is more of an introductory talk. But these, I think, are the 6 main terms that you could start off with and get into Ansible. First is inventory, then playbooks, plays, tasks, modules, and handlers. So they're arrowed in such a way because they kind of play into each other. And we'll go with inventory as our first thing to describe. So the inventory is really what it sounds like. It's a list of all of your targeted nodes that you want to automate or manage or provision from your controller machine. It has an INI-like file structure, so it's just very simple looking. It's just a list and maybe some groupings, and that's really about it. It defaults as essentially a host file that's located in etcd Ansible hosts. It looks somewhat similar to your regular etc host file, but possibly a little simpler. You can also store information about the host in them. You can store variables. You can store different ways you want to interact with those hosts if you like. And you can go from there. You can make it as complicated or as simple as you like. They can be statically created, just have like a set list that you write yourself, or you can have a list be populated dynamically through different sources. For today, we'll only be covering static in our demo. Dynamic is not something I'll be covering today. So the next thing to talk about is the playbook. The playbook, as it sounds, is the entry point to Ansible automation. It is the recipe. It is your strategy to make the touchdown in 4 downs in football. It is the playbook. It contains all the information of how you want your node to reach the desired state. What the desired state means is really up to you, but all of that is defined in this playbook, this file. And it can also store variables about the host or how it wants to get to the desired state, whether you have some, let's say, a patch configuration that needs a certain parameter in this way. You can define it here, and the playbook will play into that and use that during the provisioning process of your node. But essentially, the playbook is what it sounds like. It is a playbook. So next are plays. What are playbooks about plays? You have 4 downs to make the touchdown, so you have maybe four plays to make to get there. So to define it, it's like an executed provisioning or process from the start to finish. That's a play. So your strategy to get the next down, 10 yards down the line, that's the play. That's the play. Maybe you have 4 plays in your playbook, and that's the whole playbook. And playbooks are obviously made of plays. The language is very English, and it should be pretty easy to understand just from hearing it, I think. So tasks. It's a block that defines a single procedure to be executed. So plays are made from tasks. So each action that you need to finish that play, that is a task. And one important thing about tasks is that they're run sequentially. So there's no real confusion about how a task proceeds because it will follow one after the other. It'll be 1, 2, 3, 4, A, B, C, D. So reading it, when we get to the demo and you read the YAML file, you'll see exactly what's happening because it's sequential. Next, we have modules. So modules are the actual work unit of a playbook. They're the things that actually do what you want to do. They're the little programs that are sent by Ansible to the managed nodes. So I said that Ansible only uses SSH. Essentially, SSH copies this little program over to your node, and runs it on your node, and then removes it from the node when the job is done. So modules do the actual work, and a task calls a module. So you have a one-to-one relationship between a task and a module. It does that one thing, and then moves on to the next task, and then completes the play eventually. So the next thing to talk about are handlers. They are they're kind of like a task actually, but they're a task that only runs once at the end of a play, and they can be triggered by a task. So for example, let's say you install a web server, let's say, and you configure it. At some point, you may want to restart it if you change the configuration. So you can trigger it such that if you change the configuration, run this handler that then restarts the service, and so on and so forth. They're kind of like an end of play thing to do, like just to do cleanup or restarting services is I think how they're normally used. So you get to see that it kind of looks like this: the encapsulation of a playbook, a play, the task, the modules, and the handlers. There are additional pieces that are within it that can be in a playbook, such as variables and roles and different pieces. But we won't really be covering so many of those today for this introductory demo. And so we'll move on to the demo portion of the presentation. Let's see. It's not quite right. Some stuff there already. Let's clear out some of that stuff. Probably I should have cleared that earlier, but I changed the text size, so it doesn't look quite right. Is that fairly visible for everybody in the audience? Should it be bigger? In the back, is it okay?
Pretty good.
Pretty good. I like that. So the demo today will be kind of something of a start to finish, very basic start to finish of using Ansible. We're going to start from the installation, and we're going to go to executing a playbook and seeing the results of it. For the demo, I've already prepared some of the pieces, so we won't really need to really install, but I'm going to talk about it anyway, so we can get that out of the way. So Ansible is, I mentioned, really, really easy to install. You only need to install it on one machine, your controller machine. That could be your laptop, it could be your Raspberry Pi, it could be your main desktop. That's the only thing that actually needs Ansible. Everything that Ansible controls doesn't need anything. Well, maybe that's not true. It needs some things, but for the most part, those are all provided already on your system. You need Python because Ansible is written in Python. You'll need SSH, which is normally provided as well. So very standard things that are already part of your system, you will not need to install. So Ansible only needs to be installed once and on your control system. There are a few ways to do this. If you run a distribution like something RHEL-based, such as RHEL or CentOS or Fedora, you can just do your usual yum install or DNF install, and it's already in the repositories. But you'll need to add the repositories for RHEL and CentOS because it's in the EPEL repository. But otherwise, it's already there for you to use. For Fedora, you can already do just DNF install Ansible, and it will be there for you. Same thing goes for Debian-based distributions. You'll just use apt instead of yum or DNF. So just to show you, yum list Ansible. As you can see, I've already installed Ansible. It's pretty simple. So if you were to install it, it'd be yum install and then Ansible. Fairly straightforward. If you're running something that doesn't have a package manager of sorts, you can also install it via pip because it is Python. So that should be fairly straightforward as well. And the last thing you can do is you can install it from source, which is also actually really straightforward. The build process is not very complicated. You can also just get the binaries, and they have a pretty good set of straightforward documentation you can use on the Ansible website to get yourself started with a source installation if you prefer to be on the latest release. Otherwise, the package manager is what I would recommend. So with that out of the way, as I said, Ansible is using SSH only. So what would you need to do to have it connect to your nodes? Probably just to have SSH keys, which is the recommended way to connect to different nodes. I know it sounds really silly because it is really silly. Because it's really simple, right? It's just you just need your SSH keys, install them onto your nodes, and there you go. For this demo, I have 1, 2, and 3. If you caught that quickly, let's try that again. 1, 2, and 3. So 1 is my controller node, my controller machine rather, and 2 and 3 are 2 of the machines that it will manage with Ansible. I've already installed the SSH keys onto both nodes 2 and 3, so we can essentially already get to work. So just to show you, Ansible is installed and it should be working, and just do version and it's working. So let's interact with the nodes in some way to show that it's actually working, and with those nodes, it can actually communicate with them properly. We'll do some ad hoc commands to start with, and then we'll go into the playbook afterwards to show what that's about. The ad hoc commands aren't really too interesting, but we can show them anyway. So to use Ansible, you use the command Ansible. And the first parameter here, all, is listing the hosts you want to target. And so all of the targets would be both nodes 2 and 3. So let's do -m, which stands for module. So we'll do a ping. There is a ping module. Success. So we can successfully talk to both of our nodes via Ansible. Doesn't really do anything. It just does ping and pong. And nothing has changed about them. Success. You can see that the Ansible gives you very, very human readable output. It tells you the host it tried to access or tried to affect, and tells you the success or failure of your command, and what may have changed during the course of that command, if anything. So very simple looking, very easy. So I mentioned the inventory earlier, and let's just briefly take a look at that before we move forward. I said that the default was in Ansible, or etc Ansible hosts. So I made a really simple looking, it's a really simple looking inventory file. It just has a grouping that's called FSOSS, and FSOSS1, FSOSS2 are the nodes I have. And that's it. Of course, you could have a more complicated set of groupings if you like. We won't actually make any changes here, but let's say you had web. You wanted to host web servers on certain nodes, and we could put FSOSS1 here as well. And let's say you had database, and we put FSOSS2 in there. So you can make groupings such that hosts can be part of different groups, so they can be affected by different playbooks that affect different groups of those hosts. And you can mix and match, and you can define more about them if you like. You can also make children groups, which are composed, or parent groups, which are made out of children groups. So for example, if we have web and DB, we could have something called all, and all could be comprised of both web and DB groups. So that's a rather simple looking INI-like file inventory. So now that we have the inventory and we see what hosts we're affecting, and we've done a ad hoc command that does a ping, maybe let's try some other ad hoc commands. And instead of doing all, let's actually do FSOSS, because that's the name of our group. So using -a, we can put in different arguments. We can do something such as, let's say, bin, I guess, and date. And I suppose this should give us the date. Maybe I should put my user as well. Oh, hey, success. We got today's date and time. So these ad hoc commands are also really rather straightforward. They also, I think, are very, very English to me. You have just the Ansible command, the hosts it will affect, some parameter, whether A would be arguments and M would be for modules. For A, it would be the command you want to, for in this instance, you want to run the argument of -date, -u, the user you want to run it as, and so on and so forth. So I think it's very simple. There's not really much to it. It's much easier than I first thought when I knew nothing about Ansible. So we've run some ad hoc commands, which is cool, but not super exciting. We haven't really done anything, I suppose. We haven't really provisioned anything. We haven't changed anything, which we maybe want to try out. So I have some playbooks that I made, which are extremely simple, and you can kind of tell what they do by reading them. It installs Apache, or installs a web server, and it removes one. So let's actually take a look at what a playbook looks like. I've talked about it and what it comprises of, but let's actually take a look at what it looks like and what YAML looks like and why it's easy to read. Let's actually make this the only screen for now. So in a YAML file, to denote it is a YAML file, you have these 3 dashes at the top. That's how I know it's a YAML file. And so this is the playbook. We have really only one play in this book, and that is install and start Apache. So the directive here is the name. So the name of the play is install and start Apache. I would think that if you didn't know anything about coding, you could just read the name as like, well, this probably installs and starts Apache. Probably. And so we have our hosts, which is the group that we had before, the FSOSS group, which is the nodes 2 and 3 that we showed you before. We have the remote user. So on that machine, I have a user called Huang. That's me, and we can use that user to do our provisioning. We can use the become directives here to say I want to become root actually, because we're going to do some things to do yum install. We need to be root. We need to have sudo permissions. And yeah, that's really the first chunk of the play, setting that up. And now we have some tasks which actually do what you want to do. The first task is let's install HTTPD. And how are we doing that? So this is the module actually. So this is the yum module. There are a lot of modules that really mirror what you normally do on the command line, whether it's copying a file, running your package manager, or more complicated things. Or restarting your service as well. So you have yum. You tell it the module you want to do. And these are the directives for that module. On the Ansible documentation, they tell you really clearly what these directives do. And they have many examples to show you exactly how it works. So it may not make sense to you right now, but it should be fairly clear once you do a little bit of reading. But even reading this, I think it's not too terrible. You have the name, which is the name of the package you want to install here. And this is the state. So we talked about bringing ourselves to the desired state. And the desired state for us for this particular package is we want to bring it to the latest. So we want to install the latest version of our web server that's available from yum. The second one is a directive called copy demo file. And the template here is a module that templates a file from a source to your destination, which is a remote machine. So in this case, it would template this file or copy it over to my nodes 2 and 3. And what I'm copying is I'm copying this index.html file that's located in etcd Ansible. And the destination will be the remote machine var www.html. And we'll also change the ownership of that file to Apache, as well as the group to Apache, and also change its file permissions as well. Our next task is to enable the actual web service. So we have the service module. We have the name of the service. And what do we want to do to it? We want to enable the service. And this is what I was talking about before, that how a task can invoke a handler. By using the notify directive here, we can specify which handler to invoke based on the name. And for this one, it's start HTTPD. So we've enabled the service, but we haven't actually started the service in our provisioning here. So that's why we're having the handler do that piece. It's pretty silly, but we could have done it as an actual task, probably. But just to demonstrate how handlers work, I just want to have a very simple example. And here's the handler at the end. You have the name of it, which is start HTTPD. And then you have, similarly to the above, the service, the name of the service, and the state you want it to be in, which is started. You want to start the service. A very silly example. So let's unzoom that now. And let's clear that for a bit. So now that we have our playbook and we've seen it, how do we run the playbook? What does it look like when it runs? So it's Ansible playbook. That's the command. And all you need to do is give it the name of the playbook. And for our purposes, it's install-apache.yaml. And let's see what happens. What's going to happen? Oh no, a password is required. Oh dear. I forgot to. I reprovisioned my VMs this morning and I forgot to make the changes because I broke them last night. This is what happens when you do this kind of thing. Yeah. Well, let's see. How should we do this in a really quick way? Let's just sudo over here, actually. Let's do a really also silly thing, since we're already in the midst of doing silly things. So let's just edit. I don't think we have Vim here, actually. Let's just edit the sudoers file. Don't do this. Don't do this. Don't do this. I don't recommend doing this normally. But for the sake of doing it, we'll uncomment this line here. Don't try this at home. If you do, don't tell them I told you to do it. Yeah. So a little silly command to allow me to make this change, I think. Darn.
The def null, it's Chris's. Just get rid of the greater than def null.
Yeah, it's been a little while, actually.
Put the exclamation mark in front.
In front of sudo?
In front of W.
In front of W.
No, in front of before.
Before W?
Yes.
Yeah. There we go.
Okay, I assume that did what it did. Thank you to my fellows at CDOT. So, did it do what it wanted to do? Yes, it did. Okay. Okay, that's fine. So, well, I'm not going to bother changing FSOSS 2. For showing you that it fails is probably another good thing to show. So, it's not really got you, but typically you're required to use a password for sudo. For this demo, I want to use no passwords to just make it look very clean and nothing will go wrong. That's never the case in these demos, is it? But anyway, let's go back to taking a look over here, actually. Let's clear this up. So let's run this again, and hopefully we get some different results. For least for one of the nodes. Okay, so we did some task setup. The task setup is the initial stuff where it sets up all the tasks that you had assigned in the playbook. Yeah, that actually looks right. All the red is confusing me because it's like, oh no, something didn't work. But
Do it again for FSOSS 2.
I could do it again for FSOSS 2. But just to show you what it looks like during a failure is probably a good example, actually. In a failure, you see that all the text is in red, very clear that something failed. But you also get this JSON-like output that tells you if something changed about that task, if it changed anything. And this is false. Did it fail? It's true. What was the standard error and standard outputs? So sudo password is required. We really easily know what the problem was when we ran that command. And pretty good. Pretty good to know. But otherwise, FSOSS 1 was OK because we allowed it to use no password for sudo. And we see that the setup worked out fine for that task, or for that node, rather, of those tasks. And we see the second task was our install HTTP task. You see that something changed about FSOSS 1. Nothing changed. We installed HTTPD, that's what changed. And the copy demo file, oh no, more errors. So we see that it failed to copy the actual demo file. And let's read, actually, it's probably a good reason to read why. So again, something tried to change, but it also failed. And here's the message. Aborting because the target uses SE Linux, but Python bindings aren't installed. This is actually something I should have gone over as a gotcha earlier. For CentOS and for older distributions, this particular Linux, SE Linux Python bindings is required to be installed on the nodes. And this is not required for different distributions that already have it installed, such as Fedora, I believe, has it installed, and I think probably Ubuntu as well. But for something that's slow-moving like CentOS and RHEL, you're going to need to install those either as part of your playbook initially, or just to install them manually and just have the nodes have that already before you do any playbook stuff. But I would probably recommend adding it to your playbook so you don't become like me today. So bit of a snag there, but let's actually just do that. Let's just install that so we can see the rest of the nice output I was expecting earlier. -y lib se linux Python. So this is install the bindings that we wanted. And so the copy demo file should not fail this time. I've been saying that a lot, haven't I? Anyhow, let's run the command again, actually. Let's run the command again. Oh, hey, okay. That's the output I was more or less expecting. So as you can see, we've run this command a few times, and not necessarily on purpose, but I was planning to run it a few times, not in this way. But you see that for the task setup, it's OK. You saw that before we had changed FSOSS 1 when we did the HTTP install. But this time it says OK, because the state of that task has already been reached on that node. So you don't need to do it again. So it knows that the state has been reached, and that's the whole point of these playbooks, to reach a desired state. So each task is trying to reach that state. And now you can see that the copy demo file task has changed something about FSOSS 1, so the state has been reached. And you can see that our next task, enable the service, has also changed FSOSS 1, so that has also been reached. And our handler was invoked because of this previous task that we had it notify, please start the service now. And ignore this particular piece. This is because the FSOSS 2 is not working properly. But on the recap below, it's kind of like a sports recap. You can see your instant replay of what happened. You see that FSOSS 1 is yellow. So yellow means something has changed. And all the tasks were OK. That means they worked properly. And how many things changed about FSOSS 1? 3 things. Unreachable, it wasn't unreachable. And nothing failed for FSOSS 1. For FSOSS 2, nothing was OK. Nothing was changed. It was reachable, but it also failed. So you can get a really, really clean output just from reading the output of doing your playbook to see what has changed about your system and where you're at right now. So when you run a playbook again, it won't do anything unless it needs to do something, which is very nice. So we've supposedly changed something about these nodes. What did we change about them? So just to show that everything does work, not just that the Ansible output says something has changed. So if we do system.cll status HDBD, well, we should see that it's running, which is great. That's what we expected. And we should also see that our demo file, I believe, should be there. I believe I could curl it, maybe. Can I curl it? Yes, FSOSS 2016. There's our demo file, just some ASCII art. So you can see that everything that we did happened on the actual node itself, and Ansible wasn't just playing a trick on me, as it did earlier. That's how I'm going to describe it, yeah. So, and you can see that, was that easy? Can I press the easy button? Was that pretty simple?
Yes.
Yes, but that's probably also because this was a very simple deployment. We really didn't do anything except install a web server and had changed the index.html file. Yes?
So question, when it copied over, sorry, when Apache, going back, when the file failed to copy,
yep.
Did Apache start?
On node 2, you mean?
Yeah.
Or on node 1?
On node 1.
On node 1.
Because it said, the second time you ran it, it said 3 changes in the system. But I would hope that it would copy the file and then not restart Apache. I would hope. But
I would also hope that, actually. So again, I'm not the most initiated in Ansible, but I will ask the field. Will the field?
When at the failure, the playbook stops for that host.
That makes total sense. Thank you.
I think it depends on how you configure it too. Like, for example, with Nginx, if you don't want to restart the service if it doesn't need to, you can use reload instead of restart, and that'll just update the configs.
Also, handlers are triggered at the end of the script. They wait until...
That's true, yeah. I did mention that, yeah. Thank you for affirming that. So now that we've seen it has done, like I said, this was a very simple provisioning. It almost did nothing, I would say. So I said that was really, it's a powerful tool for your simple and non-simple tasks. And so actually, Ansible has a really good set of examples to give you some best practices on how you actually really write a playbook for an application that's potentially multi-tiered. If you have a database, you have a web service, you have different moving pieces all together. And so I did not attempt to write these because I didn't feel I had enough efficiency to write them. But let's look at something I thought was pretty complicated. So we have a WordPress-Nginx playbook here, which I think is a pretty good demonstration of how complicated something can get within reason for today's talk, at least. So we have a site.yaml, which is the YAML, or which is the playbook for this particular example. You see some similar things. You see that it is a YAML file. You see that it has this one play. And you see that it has hosts it wants to target, as well as the remote user it will become when it does what it wants to do. It's commented these other pieces because it doesn't necessarily need them, because it's being root rather than becoming some user that becomes root. So this is something I mentioned prior, roles. So you can consider roles as reusable code, like you would think in a C program. You include all these functions you want to use and what have you. So roles are fully functioning encapsulated playbooks that do what they are supposed to do. And for this case, here it does some common things. Here it likely installs MySQL and Nginx and PHP and WordPress. So playbooks, if you were to write one all by yourself, it might become really, really, really long if you had a really complicated piece of software. So what Ansible has is it has roles, which are like include files. You reuse playbooks that you've done before in smaller chunks into your bigger application. You can obviously modify it to have different parameters when you're running these roles again. But the fact that you can compartmentalize and modularize all your playbooks into smaller pieces, which then can be run in a much larger application and reuse them, is one of the strengths of writing these playbooks. So let's take a look at some of the roles briefly. We see that there is a roles directory. And let's look at the MySQL one, I suppose. So it has its handlers, it has its tasks, and it has some templates. The templates, I believe in this, are just the files, the configuration files you want to copy over to the remote machine. And let's take a look at the tasks, I suppose. So it has a main.yaml. This is similar to what we had seen before. So again, it's just another playbook. And it has some arguments here. Or rather, it looks like another playbook, but it's really just some tasks that you want to perform. So you can see that it's doing fairly similar things to what I was doing before. You have the template here where it copies the configuration file over. You have a notify to restart the service here, and such and so forth. Or rather, it'll notify the handler, which will then restart the service. And you'll try to enable it and have it start here. And you can do as many of these as you want. You can use as many roles as you want as needed for your application. So you can essentially do a very programmatic way of assembling all the building blocks of any application you want. Ansible actually has a very large community called Ansible Galaxy, where users submit their own roles and their own building blocks so that you can reuse them. And so you can build off of them to make your own applications and playbooks work as they should. So you can map your complex or simple use cases as you would like. And so let's just go back to our playbook for a bit here. And here's the retry file that was produced when we had a failure of our playbook earlier. It just kind of tells you that, well, something failed, and let's just actually just take a quick look at it. And the host that it failed on, that's what the retry will have. And so that's a brief demo of what you can expect with Ansible from very, very simple, from 0 to maybe 1 or 0.5 of the journey for learning Ansible. But I would think that the journey here was really simple. I think just going from here, you can probably get started already and make your own playbook that's much better than mine, that will actually work the first time, and that will have the needed things installed on the nodes through your playbook, not manually installing a VM like I did, or having to manually change the password to use no password for sudo. And so let's go back to our slides for a brief moment. So that was the demo. To get started, I really recommend reading the Ansible documentation. It's actually really good. That's more or less how I got started when I started researching this for this talk. Just reading the documentation was enough to get me this far, at least. And they have a lot of examples. Every module that you've seen me use and haven't seen me use has all the examples you need to actually understand how to use them, which I think is really the only part that's complicated about using Ansible. It's probably just the modules. Everything else is kind of just naming, to name the task, to name the play, and so forth. And really to structure your your application the way you want to, your deployment the way you want to. And so that's actually the end of my content for the talk. I will open up for questions that hopefully I can answer. If not, hopefully the field can answer it. Yes?
So I'm assuming you, I assume you did a lot of research on trying to figure out which configuration management system you wanted to use, and I'm guessing you chose Ansible for some reason. Can you tell us what are the advantages of using Ansible over something like Chef or Puppet?
So I described it a bit earlier, but to repeat the question actually, why did I choose Ansible? Why would I not choose something like Chef or Puppet or otherwise? I think the main point was how easy it was to install Ansible from what I initially read. All you had to do was install Ansible one time, and there are no other pieces needed on any of the nodes. And that the language was very readable from the get-go. Also, I was recommended to learn Ansible from some of my colleagues already, so that was also a good pushing point to learn Ansible. Yes?
So you just got two questions. One is the output.
Sure, let's bring that back actually. Yes?
So the output.
Let's run the playbook again actually. Okay. Ansible play.
No, I just, so when you were running and you got the output, come back to your host, does it save it into a log file as well automatically?
So
for example, you could run the playbook and go do something else, right? Or do you have to just pipe it to a log file? That was one question. The other question I had was, I noticed that the service, so for example, when you were doing the install and you never really gave the command to do it, so it automatically deciphered how to do for Yum. So how would it know for the host that it is on?
what to actually do?
Yeah, whether to use Yum or to use apt.
Oh, so we used Yum because we had the Yum module. There actually is an apt module that you can use to install for distros that use apt instead. Let's just bring up the playbook again. Actually, okay, not Apache dot YAML. So let's just bring up the playbook again. So we did use the Yum module here, which is why it uses Yum. There are some default parameters that it goes with to tell you how to use Yum, but otherwise you can define them as needed here. I believe using Yum normally it just uses with -y at least, I believe. And latest you can say, you can use the state to determine how it acts. You can also remove the package with a different state, which would be absent instead of latest, for example, absent instead of present. Really, what you do for your task just depends on the module you call. And to answer your second question about the first question about the logs, I didn't really research too much about the logging, but I know that one of the main points of Ansible was to have a really auditable language, so that you could go back and see who made these changes, what changes happened. But I can't really answer you on where those logs could be stored because I didn't really quite look into that piece. If the field could has points on that, then feel free to answer that. I guess we don't know. Hopefully I'll know for next time.
Different question. So you showed access control using sudo and SSH as root in the larger example. Are there other methods of escalating privileges in order to be able to execute things in the system?
I believe there are, but for my knowledge base, for this demo, this is all I really looked into for privilege escalation. Yes, if you'd like to.
So the command become, and that it's kind of dumb. So become yes.
Yeah, this is
Become user.
yeah, this is exactly what I have here. Yeah.
Change to any user on the system, assuming you had root access in the first place.
Yep.
Yeah.
Actually, sorry, you in the blue shirt, believe you had your hand up earlier. Did you have a question?
Oh, so the tasks install Yum, your state equals latest means that it will auto-update Apache every time you run that state, correct?
I believe so, yes. That's what the latest directive will say.
You don't want to necessarily copy-paste that, depending on your...
No. This is just a silly example.
Yes.
Yep. Are there any other further questions about the presentation? Or even comments? I would like those as well. Then maybe I should ask a question, actually. Do you feel that this is a really easy tool to use? Would you maybe start using it if you haven't already? Would you recommend it to your friends and family and mom and dad? Maybe not that far. Maybe not that far. Okay, I understand. And I think time is kind of running short for this presentation. So I'll just close it off with a few things. The next talk coming up is actually something called Automate All the Things, Introduction to Jenkins. If you enjoyed the automation portion of this talk, please come and, or actually just say exactly where you are and you'll enjoy the next talk. It's by Justin Flowers, a former colleague of mine, and he is quite good at this kind of thing, which is coming up right next. And are there any students actually in the audience, Seneca students?
I'm a student of Seneca students.
Okay. Okay, fair enough. Just indulge me for just a minute. So I'm part of Seneca CDOT actually, I'm an RA here, and we're trying to do a bit more of a open outreach to people who want to get involved with us. So I've made a few links. The first link, tinyurl.com/cdot-FSOSS, is a link to our wiki page. You can find out more about us and what we do, and if you want to get involved as a co-op student or otherwise, please come by. And the second link, cdot-public-talks, we actually have internal demos, kind of like doing talks like this, but usually they're mostly internal only and it's only for us. But we're having a few talks once each month for this semester, and the next one will be coming up in November. If you'd like to participate in them, please come by. They're open to anyone in the ITS schools, and you can go to that link to find out the schedule and the topic. And thanks for coming.
And thank you very much for the talk.